Hello everyone, welcome back to the channel. So in this video, we are going to talk about one of the important concept in Python, that is shallow copy versus deep copy. Okay, so let's understand what it is. So basically, there are three types of copy we do it usually. Okay, so let's say I have a list one and which has some element. Let's say 1, 2, 3, 4. Okay, and let's have some nested element as well. Let's say I'll have one nested element 100 and 200. Okay, so now the first type of the copy is just assigning one list to another list. Okay, so let me do lst2 is equal to lst1. Okay, so in this what happens is if I just print both the list lst1 and lst2, so you can see here both the lists are exactly same. So what exactly happens when we kind of assign one list to assign another list by using an is equal to operation? So in that case, what happens? Let's say, for example, here lst1 we are creating. Let's say we are creating it at 1000 address location. Okay, where this 1, 2, 3, and 4. These four elements are stored, and then this nested list 100 and 200. This is basically created somewhere else. Let's say address 2000. Okay, which has this 100 and 200 element. Okay, and that 2000 address what we have is basically stored it here in this. Okay, so this is how basically your lst1. So when you create lst2 equal to lst1 operation, what exactly happens is lst2 also points to this same exact memory location. And due to this, what happens is whenever we modify any element from the list 1, let's say if I do lst1 of 0, which is right now 1, I'm just trying to make it as a, let's say 100. Okay, now if you do it, now let me print lst1 and lst2. So if you do it here, what happened? You can see that 0th element got modified in both the list. Okay, so this is what happens in when we assign lst2 is equal to lst1. So that means when we use an equal to operation to copy one list to another, like both variables are kind of pointing to the same memory location, and due to that, if you modify one element in any of the list, other list will get impacted. Okay, so make sure whenever we are using an equal to operation, we have to make sure that, or we have to basically understand that both the lists are going to get modified even if you modify one list. Okay, so this is what kind of we just call it as assignment operation. Okay, so next thing that we are going to talk about is the shallow copy. Okay, shallow copy. So shallow copy we can achieve it by using either doing an lst1 dot copy. Okay, or there is a so we have lst1 dot copy method which we can assign it to lst2. So this is the one option, or there is a module called as a copy module is available, and in this copy module we have a copy dot copy method. So this is also we can use it. So any one option we can use it to achieve the shallow copy. So let's understand what is shallow copy. Okay, so let's say I have this same list, okay, with the same kind of address. So only thing that I have to do is I have to do lst1 dot copy. So this will assign it to lst2, right? And if you see, both the lists are same for now. So let's understand what is meant by shallow copy. So shallow copy means what? Whatever this 1, 2, 3, 4 address elements you see, okay, these are, we can call it as a root element, and this 100, 200, we call it as a nested element. Okay, so when we do a shallow copy, this root elements get copied into the new address, but this nested element will remain same. Okay, and due to this, what happens? If you modify the lst1 root element, it will not impact the lst2 root element. But if we modify the nested element, it will impact the lst2 as well. Okay, so how exactly this is stored in the memory? So this is how your list one, where on 1000 address we have 1, 2, 3, 4, and at address 2000 we have 100, 200, and that 2000 we are storing into this list. Okay, so when we do a shallow copy, what happens is basically for lst2, for root element, a completely new address gets created. Like for example, let's say 3000. So this is where 1, 2, 3, 4 will be stored, but that nested element 100 and 200, that same 2000 address is getting copied. Okay. Now, due to this, what happens is when I modify LST1, let's say LST1 of 0, I make it as a, let's say 1000. Okay. So now if I go back and check both LST1 and LST2, you can see only list 1 is getting modified. Okay. List 2, there is no change, right? Why so? Because for root element, the address is completely different. Okay. But if I modify the nested element, let's say if I do LST1, of this root elements are available 0, 1, 2, 3 at fourth location, right? So if I do LST1 of 4 of 0, if I make it to, let's say 1000, okay, instead of 100, I'm trying to make it as 1000. So if you do this, change happened. But if you go back and check the both the list, you can see it got modified in the LST1 as well as LST2. Why so? Because both the list are storing the address of the nested element. And due to that, whenever we modify the nested list, it is getting modified for both the list. Okay. So we have to mesh the, and this is something we call it as a shallow copy. Okay. So whenever we are using a shallow copy to create a new list, we have to make sure we understand this, that root element will be copied to the new address, but the nested elements will still be used same for both the list. Okay. So this process we call it as a shallow copy. Okay. Then we have a next concept called as a deep copy. So to achieve the deep copy, we have to basically import a copy method and import a copy module, and then we can just use a copy dot deep copy that will help us to basically do a deep copy. Now, what is deep copy? Let's understand with the example. So let me just copy this and do an import deep copy module, import a copy module, and then use the same kind of a code. Okay. Only thing is how we have to use it. We have to use something like this copy dot deep copy, where we can pass the LST1, and that is going to give us a LST2. So now what is going to happen here when we do the deep copy? When we do the deep copy, what is going to happen is basically this, let's say your list 1 is like this, okay, where at 1000 address we have 1, 2, 3, 4, and at 2000 address we have 100 and 200, and we are copying that 2000 address into our at 1000 address. Okay, so when we do deep copy, what happens? This root elements also get copied to new location. Okay, let's say 3000, and also this nested element that also gets copied to some new location. Let's say 4000. Okay, at 4000 we have this 100 and 200. Okay, and then that same 4000 is gets used here. And due to this, what happens whenever we do the elastic deep copy, you can check if I modify the LST1 of 0. Okay, let's make 100. So you can check LST1 and LST2, both are not getting impacted. Okay, you can see LST1 is impacted, but LST2 is not impacted because this root element are anyway getting copied to the new memory location. But even if I modify the nested element, let's say LST1 of 4 of 0, I make it to 1000. Okay. And now if I go back and check the LST1 and LST2, so you can see only LST1 got modified to 1000. LST2 is still on 100. Why so? Because LST2 is on the completely new address location. So even if you modify the data under 2000 address, that is only used by the LST1 and not the LST2. LST2 is using the new address. Okay. So whenever we are using a deep copy, so root element as well as the nested element are completely getting copied to the new memory location. Okay. So we have seen these three types of copying. Okay. As per the need, we can use it. Okay. If you just wanted to share the same address location for both the list, use the equal to operation. If you want to just worried about only the root element and don't worry about the nested element, go ahead with a shallow copy. And if you want both the lists completely different, even root element as well as the nested element, you should go for a deep copy. Okay. So I hope everyone understood this concept. If you have any query, please write it in the comment. If you like the video, please subscribe the channel if you are not done it, and please share it with your friends. So that's it for this video. Thanks everyone.